Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take a look at an older version of our P4. Now, the current P4 may be slightly different than the one we're going through in this video. However, most of the concepts should be the same. This video assumes a couple of things. Number one, that you've watched some of the earlier videos in the fundamentals demo series, preferably the one focusing on P3, as well as having started to look at the pointers demo series, and particularly those videos that focuses on the concept of by value and by reference variables when you're passing them to functions. So the first thing we need to do is we need to obtain a copy of our P4 instructions, as well as the P4 sample.txt, and optionally the P4 setup. Now, I encourage you for this particular video and for future videos in this series to focus less on having the P4 setup.c. If anything, it should be something that you should start feeling comfortable with creating yourself. But for this video, we're going to go ahead and leverage it, and we're going to focus on triaging our switches, as well as building the functions themselves, or at least starting to build the stubbed in functions. The other thing that would be helpful to have for this video is going to be a copy of the P4 switches so that you can visually understand how we're going to triage the arguments. Now, as you go through this video, you're going to discover that our P4 switches are identical to our P3 switches. And once again, hopefully you should start feeling comfortable with moving away from needing these setup videos. And if anything, what you can do is you can simply fast forward to the end of this video to see that you have the solution correct. So let's go ahead and get started. We'll take a look at our P4 instructions. You'll notice here that I provided for you the same set of, or sets of switches, tiers of switches, however you want to look at it, that we saw in the earlier video, and that there will be the tier 1 modes of help, 1D and 2D, and beam. And then additionally, then for the tier 2, we have to be able to support interactive and parametric mode. So fundamentally, the way that we handle the switches will be the exact same as we did in our earlier P3 project. Now, I have started by creating a P4 project. I've only done a little bit of work here. Basically, it's just some of the simple things that we would need to do for any project. Went ahead and added the comment block at the top of my code, named the file correctly, the project correctly, and so on. And I've added a couple of includes, the string.h and the math.h, just simply because we know we're going to use them. And then I've also added this block of code here that's much more of a convenience than anything, just so that we can keep track of our arguments. And we've once again done this in multiple earlier videos. If you're not comfortable with this yet, you probably should be at this point. Now, the idea here is that we want to start by triaging some of the switches that we know that we need to handle, and also taking a look as well at the argument count themselves. And so if anything, what we want to do is take just a second to look at the structure of our switches. And you'll notice that once again, it's very similar to P3 in that we want to be able to support the slash question mark as well as the slash H. For the 1D options, we want to have both slash I and slash P. And if we pass it slash P, then we also want to provide it with an additional argument from the command line so that it can be handled parametrically. In other words, we're going to convert then the string that is passed on the command line to a numeric value for Y and it. And you can see here on the right side, I've provided you some examples. Once again, encourage you to go back and take a look at your p3.exe before you proceed with this project, because you'll see that there is a tremendous number of similarities. Really, the main thing that we want to focus on is how the responsibility between our P3 and P4 has changed. And I provided you sort of the summary for this. This includes not only your earlier P2 and P3, but P4 in the future P5 and P5 modified. Main thing that we're going to focus on between our P3 and our P4 is where we gather the information, as well as where we present the information. And so in P3, we relied on our main to gather the information either using a scanf or argv, in other words, collecting it from the command line arguments, depending on whether the user wanted to use the program interactively or if they wanted to use the program parametrically. Either way, the functions were responsible for doing the calculations. And in P3, the output was the responsibility of the function. In other words, printing to the console the results of our calculations was the responsibility then of the respective functions. Now, if we move forward to P4 or version 3 of our functions, you'll see now that the responsibility for doing that has shifted to the main. Well, why is that? Or rather, how is that possible? Well, what you'll do here is you'll take a look if you have your P3 setup, and I've went ahead and created a P4 setup so that you can see the similarities. You'll notice that if you compare the function signatures between the P3 setup, where we'll focus just on the 1D version 2 versus the 1D version 3, that there are additional arguments. And specifically, you'll notice in our 1D version 3 that in addition to passing my y init by value, I'm also passing pointers or addresses of variables for my t final, my y final, and my vy final. Now, in the pointers demo series, I go into great detail about why we don't want to think of this as returning these values, but rather what we're doing is we're passing the address of these variables so that they may be updated inside the function. Now, technically, you could still leave the responsibility for printing the tables in the functions themselves, but that would sort of defeat the purpose of passing these variables by reference, meaning that we have updated the values in these variables. Why not go ahead and shift the responsibility out of the function now? And in this case, we're going to put the responsibility for printing the results of our calculations into the main. That's the big distinction between our P3 and our P4. Fundamentally, you could actually borrow a lot of the code from your P3 and simply bring it over and make some minor modifications in your P4. As I said earlier, the whole goal of this video is just to focus on the setup. So let's go ahead and get started by handling some of our switches. Once again, I would encourage you to just simply go ahead and keep the P4 switch JPEG up, the image file that I've created with that table, so that you could follow along and make sure that you understand how or why, rather, we are going to be triaging the switches this way. And so to begin with, we probably want to go ahead and handle the scenario where the argument count is essentially too low. In other words, the user simply did not pass any arguments. And so we can just simply check to see if arguments are less than or equal to 1. And if that's the case, then we simply call our help. And once again, this is an implicit call for help. Now, probably noticed already that we do not have a help function. So this is probably a great time to go about doing that, just so that we don't have warnings. So we'll go ahead and add then our prototype up here, and we're going to keep consistent with our help being void return value as well as void input argument. And then we'll go ahead and stub in our help function. And it's probably not a bad idea to have a copy of your main template around so that you can simply add a comment block. Now, I'm not going to be spending time in this video updating these comment blocks. I'm going to leave that for you to do, but rather you want to get in the habit of making sure to add the comment blocks in front of each one of your functions. Now, at this point, we simply want to follow the rough pattern that we started with our earlier projects and just make for a nice command line experience for the user. And we'll start off by having a usage print statement here. In other words, it just gives a description of what we're about to do, followed up with just a nicely structured help. And I'm just going to go ahead for right now. I'm going to put in just a couple of the basic ones, the /h, which is going to be just simply a call for help, followed by a period, and then a new line. And we want to do roughly the same thing if the user provides the /?. Now, we're going to tweak this as we go along here, so don't get too concerned with the specifics of the alignment, things along those lines. Rather, this is something you're just going to want to spend some time making it look good. But at this point now, we should at least be able to build our project. In other words, if the user provides no arguments, then it should just simply call our help and then print out at least the beginning of our help assistance. All right, so go ahead and build it. Let's verify that we've got working code so far, and looks good. Now, let's move on to handling some of the explicit switch combinations, much like we did earlier, and that is using our string compare I. We want to do an else if, our string compare I, and now we can rest assured that at least we have one argument to compare. So we can use our argv square brackets 1, and we want to check to see, did the user intend to call the help? In other words, we want to compare it to the /h, and if so, we simply want to make an explicit call for help. And likewise, with a little bit of copy and pasting here, we can handle the scenario with the /question mark. Now, you could also do this with an or, in other words, check to see both at the same time, check to see basically if /h or /question mark were passed. Once again, that's perfectly fine as long as you understand the logic. And then before we forget, let's go ahead and handle the else. In other words, if we somehow manage to fall through all of our options, we want to once again make an implicit call for help. Now, we said that we wanted to follow roughly the same pattern that we had in our P3. So you can either go back to your P3 or you can look at the P4 switches image file that I provided. But fundamentally, what we want to do now is we want to look at our 1D, 2D, and beam options, because all of those represent the additional tier 1 switches that we wish to handle. And so what we can do now is we can just simply check to see if, using string compare I, if our argv square brackets 1 matches our /1d. And if that is in fact the case, then we can simply print, for right now, a message to the user that says calling /1d. We're not going to specify whether we are calling /1d interactively or /1d parametrically, because we do not yet have enough information triaged. Right now, we're only looking at our argv square brackets 1. At this point, let's go ahead and take a second to stub in our /2d and our /beam. Once again, you should be becoming more and more comfortable with doing this and should be relying less and less on these videos to help you with triaging the switches. Now, at this point, what we want to do is we want to take one more look back at our P4 switches and specifically notice the difference between the /i and the /p. And you'll notice that both require at least an argument count of 3. Okay, and so you've got a couple of different ways that you can handle this. You can check to see if your argument count is in fact 3 and that the argv square brackets 2 is equal to /i, and then move on to the next possibility of checking to see if your argument count is 4 and that you do in fact have argv square brackets 2 equal to /p. You've got a couple of different ways that you can handle this logic. And so what I'd like to do is I'd like to provide sort of a nested if statement here. And starting with the scenario of the argument count being equal to 3, and where our string compare I matches now that argv square brackets 2 with the /i. And so if we've got this combination, then hopefully the user intended to call our program, and specifically the 1D aspect of our program, interactively. At this point, we can simply say printf calling /1D interactively. And the whole purpose behind these print statements is just simply to provide us with some confidence that we have handled our switches correctly. Now, at this point, we can go ahead and jump into the else if. In other words, if that scenario was in fact not handled, then we want to look now at the scenario where arg c is equal to 4. And our string compare I, once again, looks at our arg v square brackets 2. And if that matches our slash p, and if those two are equal, then we simply want to make a print statement, or have a print statement. This is calling slash 1d parametrically. And then if for some reason we have once again fallen through the cracks, in other words, somehow the user provided some sort of combination that we didn't expect, then we simply want to have an else, and we once again make a implicit call for help. Now, hopefully you see the pattern here. And by the way, I just noticed I had a little typo here. I meant to say slash 2d down here. And hopefully you see the pattern. And at this point, you can probably just do some effective copying and pasting here and go through and change some of your options. So in other words, we have slash 2d slash 2d. And for the slash 2 now, for the slash 2d, you want to take one more look, and you'll notice that the slash 2d parametric, you want to have 2 arguments for a total argument count of 5. Once again, I'm going pretty quickly through this. This assumes that you understand how to triage the arguments at least a little bit at this point. And so if not, you probably want to go back to the earlier videos and watch particularly the P3 setup series, where I've spent a little more time talking about this. In this case, though, we simply want to change our argument count to 5 for the 2D. And then lastly, now for the beam, we want to have the scenario where we have an argument count of 3 and slash I, which results in the beam being called interactively. And then for the argument count of 6 and parametric, we want to be able to call beam parametrically. Now, the important thing to note here is this is not the only way for us to triage these switches. There are other combination of logic that we can use, including having this all be flat, checking the argument count differently, and so on. So you can, in fact, have a different if statement or if statement structure than what I have in this video. At this point, though, it's probably a great idea to go ahead and build it just to make sure that we don't have any errors. And so far, so good. And then for the last part of this particular coding exercise, what we want to do is we want to go back either to the P4 instructions or to the P4 setup.c. And at this point, we simply want to bring over the function prototypes, add them to the list of function prototypes right now that has our help, and then go ahead and stub in these functions. Now, as I mentioned earlier, you want to rely less and less on this P4 underscore setup.c that I have provided. And instead, what you want to do is you want to get comfortable at taking those function prototypes and shifting them into working code. In this case, though, we're just going to go ahead and copy and paste this over. And about the last thing that we have to do is simply update our help to reflect those switches. And so what we'll do here is we'll go through the scenarios that we just talked about. Particularly, we want to look at the slash 1D, slash 2D, and beam parametric and interactive versions. And so what we can do is we can speed up this process just a little bit. I'm going to go ahead and sort of have a little template here. I'm just going to make some multiple copies of it. And then what we want to do now is we want to look at slash 1D slash I, and this makes a call, calls the 1D, 1D interactively. Then we have our slash 1D parametric, in which we want to provide an additional value. for reasons or for justification of why I'm picking 100, you definitely want to go back and take a look at the earlier videos or take a look at the physics demo in its entirety. Basically, it's just our y init. And this is going to be calling the 1D parametrically. There we go. Not sure why it likes that version of the spelling, but we will stick with it. And then we have /2D/I. /2D/P. And then for this particular example, then we're going to need two pieces of information. In this case, this is going to be the initial velocity as well as a theta. And then /beam. Interactive. And lastly, /beam parametrically, which is going to require now three pieces of information or three additional pieces of information: the load, the length of the beam, and the location that you wish to place the load. And this will simply call the beam parametrically. At this point, we should be ready to once again build. You want to jump outside to the command line. I'm going to CD to my P4 project, the dist folder, debug, mingw, and you'll see there's my p4.exe, and running it with no options here will simply result in the help. Running it with some sort of nonsense should also provide us with the help. /h should provide us with the help. /? should provide us with the help. /1D by itself, also the help. /1D/I should at least tell us that we've triaged the switches correctly. In other words, we're calling /1D, and specifically we're calling /1D interactively. And then we can do the same thing now to test our 2D interactive, beam interactive. And then lastly, what we can do is we can go back and test to see that we are triaging the switches for the parametric versions correctly as well. So /1D/P with an additional argument should call 1D parametrically. /2D with two arguments should call /2D parametrically. And lastly, /beam with three arguments should, in fact, call the beam parametrically. So hopefully you found this video helpful. And as always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.